Hi, welcome to Hashtag Math. And we arrived to the chain rule. I love the chain rule. It helps so much in deriving any function. You'll see. It will all make sense. So suppose you have this function. Could you imagine how it would be to FOIL 50 times that thing? Impossible, right? So we need something else to help us. The power rule tells me that when I derive x to the n, that is n x to the n minus 1. But the power rule works only when you have x in the base and a number in the exponent. But we can view these as a composition of functions. This could be a function u of x inside the function that raises to the 50th power. And here is when the chain rule comes in. So if you have y as a function of u, and then u as a function of x, in order to derive y with respect to the inner variable x, the chain rule tells us that we need only to multiply the derivative of y with respect to u to the derivative of u with respect to x. In this example, we can view y as the composition of two functions. We can write y as v composed with u, where v as a function of u is the outer function, u to the 5th power, and then u as a function of x is just 2x squared plus 3. And we apply the chain rule, which tells us that to find the derivative of y with respect to x, we need to find the derivative of y with respect to u, which is derivative of y with respect to u, is just 50 u to the 49th power, just the power rule, and multiply by the derivative of u with respect to x, which is the derivative of 2x squared plus 3, which is just 4x. And the chain rule tells us that if we multiply these two, then we've derived dy dx. So dy dx is going to be dy du times du dx. dy du is 50 u to the 49th power, and du dx is 4x. And now we want everything in terms of x, so we replace u here, and we get 50 times 2x squared plus 3 to the 49th power times 4x, which is 200x times 2x squared plus 3 to the 49th power. And that's the derivative. We could only do this, of course, using the chain rule. But let's see how this works using prime notation. Let's call h of x our original function, 2x squared plus 3 to the 50th power. Then h of x is going to be f composed with g of x, where f of x, the outer function, is x to the 50th power, and g of x, the inner function, is just 2x squared plus 3. In this notation, derive the outer function, which is 50x to the 49th power. Derive the inner function, which is 4x. And to get the derivative of h, what we have to do is derive the outer function, and as we did here for u, remember when we replaced u here, we keep g of x inside and then multiply by the derivative of the inner function. This is exactly the same thing, but using the prime notation. So what we get here is the derivative of f is multiply by 50, keep g inside, and raise to the power of 49, and then multiply by the derivative of g of x, which is 4x. And voila, we got the same exact answer, of course. Now we're going to view some examples on how to apply the chain rule. The first thing we have to notice when we apply the chain rule is that the chain rule is designed to derive a composition of functions. It is very important then to know how the functions are composed, what's inside and what's outside. In this very simple example, we can see that we first have to do this. So the first thing we have to perform is the inner function. And then we have to raise to the 9th power, so that is the outer function. The chain rule tells me to derive the composition of f and g at x, we must derive f, keep g inside, and multiply by the derivative of g. Let's do it. My outer function is x to the 9th power. The derivative of the outer function is 9x to the 8th power. Then you want to keep g inside and multiply by the derivative of the inner function. Then we take the inner function and plug it inside there. So this is 9. We plug in 3x squared plus 2x plus 1. So we keep g. And then we derive the inner function and multiply. The inner function is 3x squared plus 2x plus 1. And the derivative of the inner function is 6x plus 2. We are ready to find the derivative of the composition. The derivative of f at x is going to then be 9 times 3x squared plus 2x plus 1 to the 8th power. And then we have to just multiply by the derivative of the inner function. And that's our derivative. Another example. Again, first thing to do is determine what's inside and what's outside. So the chain rule tells us to derive the composition, you derive the outer function, keep the inner function inside, and multiply by the derivative of the inner function. So we must determine what's the inner function and what is the outer function. The things you perform first are the inner functions, and what you perform last are the outer functions. So the outer function here is the square root of x. Remember that the derivative of the square root of x is 1 over 2 root x. To find the derivative of y, we have to take the derivative of the outer function, which is 1 over 2 square root, and now you're going to keep the inner function inside and then multiply by the derivative of the inner function. So we get 1 over 2 square root of 5x squared minus 1, and the derivative of 5x squared minus 1 is 10x, and we're done. This is just a little algebra. This is 10x over 2 square root of 5x squared minus 1. After simplifying, is 5x over square root of 5x squared minus 1. Once you get used to applying the chain rule, you'll find it's easy. One more example. E to the 5x. We have to first determine what's inside and what's outside. Sometimes ln, e to the x, all those functions inside an expression might be confusing. Here's the tip. The inner function is the first thing you do if you imagine you're plugging in a number. So imagine you're plugging in, let's say, a 1 in f. What is the first thing you do to that 1? First thing you're going to do is multiply by 5. So this up here is the inner function. The first you're going to apply. And then the outer function is going to be e to the x. So the outer function is e to the x, and the derivative of e to the x is e to the x again. So to derive f, we derive e to the x, which is e to the x, but then you keep your g of x in the argument of e and multiply by the derivative of the inner function, which is 5x. Then this is e to the 5x, and the derivative of 5x is 5. So my answer is 5e to the 5x. Easy. In this example, we have e to the sine x. What's the inner function? What's the outer function? I guess you already know. This you perform first is the inner, and e to the x is the outer. So the outer is e to the x, whose derivative is e to the x. To derive y, you want to take the derivative of the outside function, keeping the inside function there, and multiply by the derivative of the inner function. And then we get e to the sine x times the derivative of the sine, which is the cosine of x. And we're done. We've arrived to an example of the composition of three functions. We have e to the sine of x squared, e one function, sine of x one function, x squared the other function. So you have to detect the most outer function. Imagine you're plugging in a number. Let's say you're plugging in a 1. The first thing you're going to do to that 1 is square it. So the most inner function is squaring. Then you take the sine, and lastly you do e. So e is the outer function and sine of x squared is the inner function. To derive y, we have to do the outer derivative, which is e to the x, and keep the inner function and multiply by the derivative of the inner function. You see, now we have to apply the chain rule again because we have a composition of two functions, this being the inner function and the sine being the outer function. So to finish deriving y, we apply the chain rule again, e to the sine of x squared, and then we apply the chain rule here. The outer function is the sine. The derivative of the sine is the cosine. So we have to take the cosine, keep x squared there, and multiply by the derivative of x squared. So this is e to the sine x squared, cosine of x squared, times the derivative of x squared is 2x. And let's just write it nicely. This is going to be 2x e to the sine x squared, cosine of x squared. Thank you.